The James Webb Telescope is already delivering incredible images of our universe. But there's one that has caught the attention of astronomers and cosmologists alike. It's this image right here, and it's an image of what we call the early universe. And when astronomers looked into it, they found that not only was something off, but it could potentially turn our entire understanding of the universe on its head. And it shows us what we call the cosmic web. You may have seen this before, because this is untactually the first time we've seen this particular thing. Because of this magnification, we're able to see galaxies that are much more distant than we normally could. Galaxies that are normally too small and too far away to be seen with even the most powerful telescopes are suddenly visible thanks to this magnifying effect. In effect, we're able to peer back through time and see some of the earliest galaxies in the universe. Alright, now back to the video. The answer to this mystery could change our understanding of the universe forever. You see, there are two ways that we measure the age of a galaxy. The first way is by looking at how far away it is. As we said before, the most distant galaxies are also the oldest because they're the ones that are the farthest away. But if future observations can confirm this, then it will be a major breakthrough in our understanding of the universe. It would mean that we need to go back and rethink some of our most fundamental assumptions about cosmology. It's seen things that were previously thought to be impossible, like black holes that form stars. And it's even seen things that we never even knew existed, like the atmospheres of planets outside of our solar system. The James Webb Telescope is truly a once-in-a-lifetime event. It's the kind of discovery that comes along once in a generation. And it's the kind of discovery that will change our understanding of the universe forever. The second way is by looking at the light that comes from the galaxy and then working backwards. Alright everyone, that is the end of the video. I hope you enjoyed this episode, and I hope you learned something new. Alright everyone, that is the end of the video. Thanks so much for watching. I hope you enjoyed this video, and I hope you learned something new. If you did, be sure to hit that thumbs up button and subscribe if you haven't already. And I'll see you next time. The James Webb Telescope is already delivering incredible data that's allowing us to see the universe in a whole new light. We're able to see things that are much farther away and much more detailed than we ever could before. And this is already leading to some incredible discoveries. We know that the light we see from distant galaxies takes billions of years to reach us. So by looking at the light that comes from a galaxy, we can work out how old it is. That's why the James Webb Telescope has been such a game changer. They looked at how far away the most distant galaxies are and worked backwards from the light that they emit. Some have argued that the universe didn't expand very much in the first few billion years, while others have argued that the light from distant galaxies is being affected by something, perhaps dark energy or some other unknown force. But now it seems we might have an answer. This strange galaxy in the James Webb image might be the missing piece of the puzzle, and they've come up with two very different numbers. It should unexist because it would mean that the universe expanded faster in the first few billion years than it did after that. And if that's true, then it would explain why the two measurements of the age of the universe are so different. This would mean that the universe is actually much older than we think. It would mean that the universe is actually about 13.7 billion years old, not 90 billion. Using the first method, they find that the universe is about 90 billion years old. Using the second method, they find that it's about 13.7 billion years old. And this is a huge discrepancy. It's a difference of nearly half the age of the universe. Not only can it see things that are much farther away than any other telescope could, but it can also see things that are much smaller than any other telescope could. And this means we're able to see things that are much more distant than we ever could have before. In fact, it's just a few months ago that the European Space Observatory released this image, which looks remarkably similar to the one from James Webb. It's allowed us to look back through time and see some of the earliest galaxies ever. We know that the universe expanded dramatically in the first few billion years after the Big Bang. This expansion is what caused these galaxies to be so far away in the first place. And because of this expansion, we expect the most distant galaxies to be the ones that are the farthest away. But this galaxy isn't the most distant galaxy in this image. In fact, it's not even close. There are multiple other galaxies that are clearly farther away than this one. So what's going on? These galaxies are so far away that they're practically invisible. But with the help of the James Webb Telescope, we're able to see them. And this is giving us an unprecedented view of the early universe. But there's one thing that's a bit strange about these images. If you take a close look, you'll notice that the galaxies in the background don't really look like galaxies. Instead, they look more like tiny dots of light. And that's because they are. Most of these galaxies are so far away that they appear to us as just a single point of light. But there are a few that stand out from the rest. A handful of them actually do look like actual galaxies, just extremely distant ones. And the most notable of these is this galaxy right here. It's one of the clearest examples of an early galaxy that we've ever seen. And it's incredibly detailed. But when astronomers took a closer look at it, they noticed something strange. This galaxy wasn't where it should be. So what gives? How are these images so similar? Well, it's because they are. They're looking at the same thing. The image released by ESO is actually the first ever scientific image taken by the James Webb Telescope before it was finally released to the public. So what is going on with this image? What does it mean for our understanding of the universe? And how could it be possible that this image broke cosmology? This is the space race. The light that you're seeing from these galaxies is 13 billion years old. It's just now reaching us. We're literally seeing back in time. But something about this image doesn't seem right. Something seems off. And it's incredibly massive, containing hundreds, if not thousands, of galaxies within it. But what's really interesting about it is that it's sitting in front of a huge wall of galaxies, creating what astronomers call a gravitational lens. Here's how that works. Imagine you have a piece of paper and you place a heavy ball on top of it. The ball will cause the paper to sag downwards. If you were to roll a marble across the paper, it wouldn't travel in a straight line. It would curve around the ball. The exact shape that the paper makes is very similar to the gravitational field around an object. So when light passes by a massive object like a galaxy cluster, its path gets distorted by the gravity of the cluster. This creates a warping effect in space-time. And this effect can actually bend and magnify light to the point where we can see things behind the massive object that created the gravitational field. This is what's happening in these images. We were able to use the gravity of the galaxy cluster to see all of the galaxies lying behind it. This image is one of the first released by NASA from the James Webb Telescope. It's a composite of data collected by 4 near-infrared instruments. What we're seeing in both of these images is the galaxy cluster known as SMA CSO 723. It is about 4.6 billion light-years away. It's not just the light that's being bent either. It also gets magnified. The reason that this image has been such a big deal is because of exactly this. Here's the thing. Now, before we get into the possible solutions for this apparent paradox, so here's the problem. Astronomers have used both of these methods to measure the age of the universe. And this brings us to the present day. For decades, astronomers have been trying to figure out why these two measurements don't match up. You see, if this galaxy is really as far away as it appears, then it shouldn't exist. Of course, this is just one galaxy, so we can't be 100% sure that this is the answer. And it's not just this galaxy that could rewrite our understanding of the universe. For example, the James Webb Telescope has already seen some of the first galaxies that formed after the Big Bang. I, for one, can't wait to see what it finds next.